All right, so welcome back. Polynomial functions continued, minimum and maximum of these polynomial functions. So what we're going to be trying to find is, so these minimums and maximums, there are local minimums and maximums, and then there's absolute ones that we have for the overall function. So I'll try to tell you and distinguish between the two. Sometimes we have them, sometimes we don't have them at all. So now these minimums and maximums, whenever you have a function, this isn't just for polynomial functions, just polynomial functions are probably a little bit easier to try to comprehend this concept with. But these minimum and maximums, you can think of it as basically these hills and valleys that we see. So a minimum would have been, so now for the time being, you can think back of quadratics. So it's almost like this little valley that we have or that we create. And then a maximum is something of like a little bit of a hill that we create. Now there is something peculiar that happens whenever you're talking about minimums and maximums. You don't typically study that in kind of grade 11-ish because you may not have talked about things like derivatives, which typically come in calculus, but you have talked about slopes, and you've studied slopes by grade 11 in quite a little bit of detail, and notice that at these minimums and maximums, so at these kind of points right here, you know, at the valley or at the hill, so the lowest or the highest point, if you kind of came across and you were going through, you would have noticed that you would have had these slopes being equal to 0 at these particular points if you put a tangent and you try to align it with that particular point. So, you know, you can see that here, and then also you can see that right here, that if you had this little tangent and you came across, it would have been going down, 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 then it kind of flattens out and then it goes and starts to go up, you know, if you had a straight line that you were able and trying to attach. So keep that in mind. So that means slopes, okay, are, okay, at these minimums and maximums equal to 0. So that's what we typically will see. Now, as you get to higher grades and you start finding out how to take kind of derivatives, you know, that idea of that slope and then the derivative at these minimums and maximums will come handy for you. For this particular concept today, I just want you to know these minimums and maximums. And you might say, well, I guess stop the video right now because we've seen these in quadratics, right? Minimums and maximums. And you're correct. You know, I guess I could kind of say, all right, let's pause it, okay, and then off we go. But there are situations in higher order polynomials, especially as you get to the 4th, 5th, 6th, 7th, and so on, that you will find that these minimums and maximums actually happen all over the place. And some of them are called local minimum and maximums, and some of them are maybe the entire absolute for the function. So we'll see that, and I'll show you through an example what I mean by that. So let's take a look at Desmos. And now here for Desmos, I'm going to load it up. And we're going to create, so we'll do it in fast forward fashion. All right, so here is, I guess I put it to the 5th order. So we'll see what that's going to give us. Now, okay, let me first zero all of these out. All right, so I'm going to zero out these higher ones first. So if I put this at 0, this at 0, this at 0, and these ones, okay, we'll go back to the quadratic just to kind of refresh ourselves. All right, so the minimum for quadratic in this case, because as you can see, would have been the point that we had at the bottom of that valley. Now, this is an absolute minimum because it is the smallest value. So the value is actually 0.75. So I guess 3 over 4 for this particular case when A2 is equal to 1, A1 is equal to 1, and A0 is equal to 1. And that would have been the absolute because that is the only minimum you have. So it's the only valley that we run into in this entire quadratic. And it is definitely the smallest value for our output function that we would obtain. Now we can, of course, so if I switch these, you know, I can make these a maximums. So depending on the value of A2. Now we're familiar with that, right? And you're familiar with these, so this would have been the absolute maximum that we have, or just just a maximum of this particular function. So it would have been, again, at this particular point. So approximately 1.208 would have been the value of your maximum, and that happens at x is equal to 0.417, approximately, probably here because it's rounding. Now, if you start making these higher and higher, so as you make the orders higher and higher, you will notice that you will have something funny happening. So for instance, so let me now introduce, so I'm going to make this one not, for instance, be equal to 0 anymore. So let's take a look and see here. So I'm going to make this kind of like that. And this brings about, okay, so notice for the value of negative 0.3 for A3. So I've changed this. It looks like a cubic because if I blow this up, right, so it looks like a cubic, it goes off to infinity up and then infinity down. And because A3 is negative, that's why you have that mirror image of it. And something interesting happens here. So here it seems that I have a valley at this particular point, and then here it seems like I have some kind of a maximum, which is a hill. Now, but these ones are not called absolute maximums and minimums because the function itself definitely has higher values than these. So in terms of the maximum, so as you can see there, 1.191, you can clearly see that, I can keep going and it has a much higher value. It actually doesn't have a maximum at all, an absolute maximum, because it goes on to infinity. But this is called a local maximum. So this right here would have been called a local maximum because it's local to that particular area. So if I zoom in here, for this area, this would have been the maximum. So let's say give or take between -1 and 1.5, that would have been the maximum. And that is called a local one because of the fact that it is interior within the function itself for the inputs that you provided. So that means that this right here, so this valley that I see here, this would have been called a local minimum. And this local minimum, again, it's not the entire, so it's definitely not a minimum at all because I can keep going here below it, right? I have values here that I can just keep going and make them smaller and smaller. But locally within here, so between certain values for the input, this indeed would have been a minimum. So this brings about kind of this explanation, and hopefully now you can understand what kind of local and maximum minimums are. Now, can you have more than just one of them? Well, you might have none at all. So if I, for instance, shift this around, okay, so notice right here, so I might have some, but if I make A3 bigger, well, here there are no valleys or hills. So I don't have any local or any absolute maximum or minimums at all. So for polynomial functions, you will run into possibly local minimum or maximums or not. It will depend on the actual polynomial and the coefficients of it that you have. Now we can make this even bigger and bigger. So for instance, let me make it kind of funky here. And then I'm going to start introducing, right? So let's say if I introduce something like this. All right, let me do that. Okay, so here's some funky. This is now to the power of 4 because I made A4 equal to 0.1. And in here, so what you'll notice is like, well, that's interesting. So this point right here, if I zoom in here, now because this is of order even, we know that we're going to have either a maximum or a minimum. Now in this case, so it looks like I have two. I have a minimum here and a minimum here. Now the one on the left, okay, so that valley, which is at negative, I guess, 1.815, and it provides us negative 1.889, that would have been called a local minimum. It's local to that particular area where this would have been the minimum. This, however, so this one right here that I have here, there is no further value for the function which is lower than that. So that is basically your minimum overall, or your absolute minimum that you carry. And so within here, that's how we would distinguish. You have a local one somewhere around here, and then you have an absolute one, okay, or the minimum in total, and it gives us a value of negative 8.183. And using decimals, we can see that visually quite nicely. It isn't that easy to find when you just have a polynomial in general. And typically, kind of in grade 11 when you're studying these concepts are meant to give you kind of a primer. So it's trying to prime you for the next courses that you take, maybe on advanced functions and then maybe calculus. And then you can see that those minimums or maximums that you have, keep in mind what I said in the beginning about the slope. That the slope, if you put a tangent, would have been 0. Because that's going to be useful for us, and it's going to be a way to find these minimums that we carry. Now, within here, I do have a maximum happening, but this is a local maximum, right? Because I clearly have higher values than this on my function. So that would have been a local maximum, and I only have one. All right, so I have two valleys, I have a hill, and this is what happens. Now, of course, I can keep making this more complicated, okay, and keep making it crazier and crazier as we go through, and certain different things will happen. But I think from this example, you see and hopefully distinguish between local and absolute maximum and minimums for these polynomial functions, and actually for any function that you will have. All right? Okay, so I'm going to stop the video here. So that was my goal within this video, to try to give you these. Of course, you can make the orders higher and higher. I don't think it's necessary. Now, is there a maximum number of these minimums and maximums? There is, right? For each individual polynomial that you'll be given, you can have certain number of changes in these hills and valleys that you carry. And I do encourage you to utilize decimals to play around with this yourself, and then see, how those functions actually can change. All right, so thanks for watching. See you in a future video. Bye, everybody.